Okay, let's do some more section 10.2. This example here says x to the negative fourth times x to the negative fourth divided by x to the second. We want to have an example with using rational exponents, assume the variables are positive. So we're just trying to simplify this. Look at the top here, x to the negative fourth times x to the negative fourth. You can multiply those together, add the powers, you're going to have x to the negative 8th. And once you have that, I would say you have x to the negative 8th on the top, which is a smaller power than x to the second on bottom. I can toss that down below and multiply it instead with x to the second and have it as x to the 8th on the bottom. So it will end up being 1 over x to the second times x to the 8th, which ends up being 1 over x to the 10th. Actually, we can look at the tutor mode really quick. They should show the same thing in the solution part. I guess they do it with the powers, well, everything's the same in terms of what I said, but you have x to the negative 8th up here. It looks like they tossed the second power up top as negative second. Subtracting the power, you get negative 10, and then you finally could toss it down bottom as 1 over x to the 10th. So far so good there. That doesn't really give us the fractional powers here, but this one will. If you just have simply a 1/2 power, and you're raising it to 25 over 9, remember that 1/2 power is a square root. We're trying to actually enter the simplified expression in the box below. If I square root the top and I square root the bottom, that's the same as 5 over 3. So that should be pretty quick to do and get a final result. Okay, so that's one of just the basic ideas, is that if you have a 1/2 power, that's a square root. If you have like a 1/3 power, that's a cube root. Whatever's on the bottom of the fraction tells you the root. Sometimes you'll have numbers on the top as well. Those are just your basic power. Okay, so look out for values on the bottom. This one jumps back and just says give us the rational exponent. You don't have to worry about the fact that 1/2 means square root. They're just saying work with these numbers and tell me what you get. Commutative property says that I could do 8 times 4. So right off I know that I'm going to have 32. And then x to the negative first times x to the 1/2 times x to the negative 2. If I add those powers up, negative 1 plus negative 2 is negative 3, plus a 1/2 would actually give you a negative 2.5, or a negative 5 over 2 when you go for a common denominator and put it all together. So if you have a negative 5 over 2 power for x, that's the same as having a positive 5 over 2 power for x on the bottom of the fraction. So I believe, let me see how they'll let me do this. See how I push the fraction button again, the little slash. It allows me to make a fraction right here with the power. So you have 32 over x to the 5 over 2 power. Is your result. Okay, 16x to the third to the power of negative 3 over 2. Either they could have you flip this thing and say 1 over 16x to the third parentheses to the 3 over 2 power, or they'll distribute the negative 3 over 2 in. Both ways are valid, but it's hard for me just to use words to show you this particular problem. So let's see what they do. They take the negative 3 over 2 as a power, and they multiply it with each of the powers on the inside. So 16 to the first becomes 16 to the negative 3 over 2. X to the third becomes x to the 3 times negative 3 over 2 power. What they do from here, which this seems like a real magic step here, they take 16 to the negative 3 over 2, and suddenly it becomes 1 over 64. Okay, what happened there is that they flipped this, and called it 1 over 16 to the 3 over 2, they recognized that the 2 on the bottom is a square root. So when you square root 16, you get 4. But then when you cube 4, 4 times 4 times 4 is 64. All of this happened on the bottom, so you get 64 on the bottom. Pretty tricky, but just imagine that it becomes 1 over 16 to the 3 over 2, and then you just make use of the definition of a fractional power to create what the number should be. The other one's a little more straightforward in that I get x to the, when you multiply powers, negative 9 over 2, and because it's a negative power, I can write it as a positive power if I throw it down to the bottom and multiply with the 64 that's there. So that's why your final answer is 1 divided by 64 times x to the 9 over 2 power. Alright, this one here looks like you can assume all the variables are positive. Doesn't make a difference though because of the odd root. They want us to change the following expression to an equivalent expression in exponential notation. The thing is with this, if you cube root y cubed, you're just going to get y. If you cube root y cubed, you're just going to get y there. So y times y is y to the second. So whatever you would get, let's say it didn't come out quite as nicely, you might get a fractional power that you convert from that. You get one here as well. And then when you multiply, you've got to add powers. So you might have had to add a couple of fractions together, depending upon the example. This one just kind of happens to come out nicely, though. This one's a little bit different. They want you to express it in exponential notation, so they want these as powers. A fourth root is a 1/4 power. A fifth root is a 1/5 power. Let's go to the tutor mode so you can see that it becomes a set of parentheses when I say y to the 1/4 raised to the 1/5. You end up with powers that are kind of stacked this way. Remember that a power raised to a power is a multiplication idea. So 1/4 times 1/5 gives you 1/20th. Y to the 1/20th. So they want the final answer as a fractional power, but what that means to you also is that the answer is the 20th root of y, which is kind of weird. But that would be, if they say exponential notation, they want the power instead of the root, so, or instead of the radical, so you could do it that way. Okay, I've got a little more time here. Hopefully we'll find a couple other key examples. They want you to write the following as equivalent expression in exponential notation and then simplify. All variables are positive. So on the top, you should have x to the 5 over 2 because you've got x to the 5th square rooted. The 5th power is the top of the fraction. The square root, the 2 that goes with that, is the bottom part of the fraction. X to the 5 over 2 means the same thing. On the bottom, x to the 5 over 3, or excuse me, yeah, that's what it will be, but x to the 5th cube rooted will be x to the 5 over 3. If I want to put them together, the rules of power state that I can subtract, I can basically change the sign of the exponent if I want to move it, or if I want to just kind of subtract the bottom from the top, I can always kind of do that automatically too. 5 over 2 minus 5 over 3, remember you'd need a common denominator. So if I multiply the top and the bottom of this fraction by 3, I'd get 15 over 6. Top and the bottom of this one, I'd get 10 over 6. I multiply by 2. 15 over 6, take away 10 over 6, is 5 over 6. And that's where that power comes from right there. So x to the 5 over 6 power would be your final result. So I think this gives you some examples to follow, but definitely let me know if you have questions, if you want to see more things done out, because I know this section can be fairly tricky.